Hi, everybody. In this video, I will show you how to write up a two-sample t-interval. So let's go ahead and read the simultaneous round table. It says the Chapin Social Insight Test is a psychological test designed to measure how accurately a person appraises other people. The possible scores on the test range from 0 to 41. During the development of the test, it was given to several groups of people. Here are the results for male and female college students at a liberal arts college. All right, so the data is summarized in the table. We have that the male sample size is 133 with the average of 25.34 and standard deviation of 5.05. And that females sample size 162 with an average of 24.94 and a standard deviation of 5.10. So keep in mind when they say the average, that is from a sample. It is X bar that we are given. All right, so the first thing we can do is, since we are asked, it says, does the data support the contention that female and male students defer an average social insight? Use 96% confidence to make your conclusion. All right, the first thing I would do is enter the statistics into our calculator. So let's go ahead and enter that. Since the male have a bit of a higher average, I would enter the male sample first, because remember, we're going to be looking at the difference of the two. So you want to use the larger number first. That way, when you take the difference, you'll have a positive result. But if you do it the other way around, that's fine too. You just need to interpret it a little bit differently. So let's go ahead and enter that data into our calculator. First thing we're going to do is go to Menu, Statistics. We're going to go to Confidence Interval, and then from there to a two-sample t-interval. Once we get to a two-sample t-interval, you're either going to be asked to enter data or stats. Data is when you're given a list. We do not have a list here. We have statistics. So we're going to press stats and then OK. From here, you can see that it's asking for the first mean. So I'm going to enter the male average, which is 25.34. The standard deviation is 5.05. And the sample size is 133. I'm going to go ahead and enter the female now. That is 24.94. The standard deviation for the female is 5.10. And the sample size for females is 162. All right, scrolling down. So we want to create a 96% confidence interval. So that I'm going to change this to 0.96. And then when it asks to pool, you always leave it at no. All right. So I have never really seen a situation where you change it to yes. So yes means their variances are the same. We are not given their variances are the same. So by default, always leave it at no. All right, so let's take a look at our information. I have right here that lower bound, upper bound, the mean difference, and then the rest of the information. So I went ahead and I cut and paste this into our document, which is right here. And let me just show you through all the steps right now. So the first thing we should do is state and check the conditions. So we're going to do that twice for both samples, for the male and the female. So the conditions are the same, where you're going to check to see if it's random, whether their sample size is greater or equal to 30 or normal, and if the population is greater than or equal to 10 times n. So I went ahead and kind of in paragraph form went through the two samples together. So the first one right here, you can see state and check conditions. We're going to assume both samples were randomly selected, because in the paragraph, it doesn't say anywhere that it was they were randomly selected. So we're going to assume both samples were randomly selected. We're going to assume males and females' behavior are independent of one another. Both samples of males and females are greater than 30. You could see that the male sample here was given as 133. That is greater than or equal to 30. And the female sample is 162, and that is also greater than or equal to 30. Now, the last condition where we write that the population is greater than or equal to 10 times n, we're going to do that for both samples. So there are more than 1,330 males and 1,620 females in the population. Take a look here. Population is greater than or equal to 10 times your n. And I showed the same thing for females as well. We will say conditions met, and we will use a 2-sample T interval. Now, since we are asked to use a 96% confidence, if you remember how we do that, 96% is in the middle. Therefore, we have 4% left over, and we're going to divide that equally to both tails. Now, when you want to find the T-crit or the critical value, remember we are using mean, so we're going to use a T model. But however, the sample size is so large that whether you would use a Z or T model, because our sample size is large, if you remember that the larger the sample size, or when your sample size gets large enough, it will resemble your T model will resemble a normal model. So therefore, if you were to do inverse norm, you probably would get very close to the same value as we do inverse T. So the area here on the left and on the right happens to be 2%, which is, by the way, 0.02. So you cannot enter 2% in your calculator, but you can enter 0.02. So to find the T critical value, you're going to go to inverse T, area is 0.02, and I use the degrees of freedom from the calculator. When we entered the 2 samples, we were given degree of freedom right here of 282.952. So using technology, you could enter the degrees of freedom, and our critical value is therefore 2.06. Now, we need this critical value when we're doing the mechanics. So taking a look at the mechanics, the formula is always the same for confidence intervals. It is a statistic plus or minus your critical value times the standard deviation of the statistic. That equals the lower and upper bound. So as I've mentioned many times, you want to write your formula in words. You don't have to write it in symbols, but I wrote the symbols below. So remember, the statistic right here is actually the difference of your 2 means, your sample means. So we are given that the first one is 25.34 minus the second one, 24.94. And if you actually subtracted that, you would get that the mean difference right here is 0.4. Okay, that's subtracting both means. Plus or minus our critical value, which is 2.06. The standard deviation of the statistics, so you need to look in your formula sheet, you're given the standard deviation for 2 samples. So that will be the square root of the first standard deviation squared over your sample 1, which in this case was the males, plus the second standard deviation for the females squared over the sample size of females. And that is equal to our lower bound, which is negative 0.8247. Upper bound is 1.6247. Now, how do we interpret that? We are going to say we are 96% confident that the true mean difference of scores for social insight is between 0.8247 lower and 1.6247 higher for males than females. Now, the negative here indicates that the first sample you entered is this amount lower than the other sample. So this is why I said it is between 0.8247 lower and 1.62465 higher. Now, to answer the question that was originally asked in the beginning, it asked us, very important, It says, does the data support the contention that female and male students differ in social insight? So if we were to do a hypothesis test, a two-sample hypothesis test, in our hypothesis, we would write that the null would mean that the mean, the population mean of males is equal to the population mean of females. That means if we take the difference, you can see right here that that difference is 0. That indicates that they are not different, that they are the same. Now, our alternative would mean that the mean of the males is different than the means of female. In other words, if we took the mean of males and subtracted it from the mean of females, that would not equal 0. Now take a look at our lower bound and upper bound. Our lower bound is negative and our upper bound is positive. That means 0 is within our interval. When 0 is within your interval, that means you are saying that there is no difference between them. They are the same. So to answer the question, we would say since 0 is in our interval, the data does not provide evidence that males and females differ in social insight. And that's pretty much how you would answer the question. Now, if we were to do a hypothesis test, we would fail to reject. We would fail to reject because we would not have sufficient evidence that they are different. In other words, we would go with the null hypothesis and we would stick with that.